This is Math 1, Section 4-2, Solving Systems by Using Substitution. And remember, when it comes to, whenever you see solving systems of equations, okay, that we're solving systems, the method we're using is substitution. But solving systems is always the same thing. We are finding the point at which the lines cross. So what we're going to do is we're going to be introduced an algebraic method. In 4-1 we learned how to do it by graphing. Here we're going to learn how to do it by solving. Okay. And there's lots of reasons why. Maybe the solution doesn't fit onto our graph, or it's really hard to tell. The answer is a decimal or a fraction, and the graph is hard to use. So we need another method. And the substitution method allows us to replace values with things that have the same value. So for example, when you look at something like this, y equals 2x plus 7. So what that really means is anywhere I had a y, I could replace it with 2x plus 7. It's kind of like generic medications. They're the same thing. They do the exact same thing. They just have a different label on them, but they are the same thing. So this one's labeled y, and this one's 2x plus 7. You can think of the 2x plus 7 as the generic, and y as the name brand. They're the same thing, and you can change them out, and it is not a big deal at all. So what we want to do is we're going to try to solve these. We want to find out what x and y is. Well, you can't solve for two variables simultaneously. It's a problem. So we need a way to change the problem so we can solve for one variable at a time. So what we're going to do is go ahead and make sure that we find something we can sub for. So this is kind of the transitive property. Since 2x plus 7 equals y and x minus 1 equals y, well, if they both equal y, then they both equal each other. So now I'm going to go ahead and solve for x. And I get x plus 7 equals negative 1. Subtract 7 to both sides, and x equals negative 8. Now, if you remember, I said the solution is the point in which they cross. Well, I need an x coordinate and a y coordinate. All I've got here is an x. So now I need to actually substitute again. And in this case, I now know what x is. Everywhere I see an x, I can go ahead and put a negative 8. And it doesn't matter which equation you sub back into, just pick one. So I'll take this bottom one here, and I'll say y equals, and it's always a good idea to use parentheses when substituting. Negative signs can cause you problems. Go ahead and add the opposite, and y equals negative 9. So the actual answer, the way that I want to write it, is the coordinate point negative 8, negative 9. If I was to graph these using the slope-intercept form, or y equals mx plus b, I could graph them and they would cross at that point. Okay. Now I'm going to go ahead and use a blank piece of paper here. These next couple examples, I'd probably recommend the same, is that it's really hard to fit all the work we need to do inside the workbook. So I'm going to use a blank piece of paper to make sure I don't run out of room. We'll cram the stuff in there. So I'm looking at number 1. This is at the top of page 241. And number 1 says, and it's in this to solve, and I get x plus y equals 8. And I get y equals 3x. Okay. So this one looks a little different, but it's the same idea. And so here's the process. Whenever you use substitution, you need to get one variable by itself, and it doesn't matter which one it is. So I look here and I go, this y is by itself. So this is set up quite nicely. So now I know that 3x and y are the exact same thing. So what I'm going to do is, instead of put a y there, I'm going to put a 3x because I know they are the same thing. And so I'm going to substitute, and this is what I'm going to get. You can see how that's not very hard to solve. Combine like terms. And x equals 2. Okay, so now remember, you got to go back and plug in for the y, and it doesn't matter where you plug in at. I'll go ahead and plug in right there. That's a pretty easy spot. So I'm going to say y equals 3 times 2 and y equals 6. So my answer, and remember, it needs to be written as a coordinate point. Okay. And once again, that was number 1. Number 2 says 2x plus 2y equals 38, and y equals x plus 3. And remember what I said, try to find a variable by itself, and this y is by itself. So I know that this x plus 3 can be substituted in for that y value because it equals y. So I'm going to get x, 2x. Now be careful with this because you're only substituting in. So I got to put it in parentheses, and you're going to see that I'm going to have to use the distribution property. And I get 2x plus 6 equals 38. Then I get 4x plus 6 equals 38. Subtract 6 to both sides. And I get 4x equals 32. Divide by 4. And x equals 8. And once again, once you find one variable, go back and plug in. And this one looks like the easiest spot to put it right there. And I'm going to say y equals 8 plus 3 and y equals 11. And once again, rewrite it as a coordinate point because we're looking for the spot on which they cross. And it's 8, 11. Alright, so let's look at problem number 2. This is still on page 241. It says solve for a variable and using substitution. So this is going to kind of get progressively harder. So what I'm going to notice here is in this next question, I'm looking at the got it, part A, is I get something like this. (6y plus 5x equals 8, and x plus 3y equals -7. Okay. And so I told you in the previous example, for this to work, I need a variable by itself. And if you look at this, there isn't any variable all by itself. But this x is pretty close, and it's not that hard to get it by itself. So I'm going to go ahead and subtract 3y to both sides. And I get x equals -3y minus 7. Now, what tends to happen here is I got all these equations up here, and it get kind of tricky. So what I'm going to do is I'm going to box the two that I'm looking at. Okay. So I didn't change this top one, but I did change this one down. So these are the two that I want to look at. And I got an x by itself, so I'm going to plug in right there. So I'm going to come over here and give myself some room. You can see why I told you I'd probably do this on a separate piece of paper. And I get 6y plus 5 times, remember this goes in parentheses here, -3y minus 7 equals 8. And so just to remind you, what's the goal here in the substitution method is to get an equivalent equation with only one variable in here. As you see, everything in here is just in y. So we're looking at something like that, and we get 6y minus 15y minus 35 equals 8. And then I'm going to go ahead and combine like terms, so I get -9y minus 35 equals 8. I add 35 to both sides, and I get -9y equals 43. I divide by -9, okay, and I get y equals 43 over -9. Now that's a little bit disheartening, I know, because most people get really bogged down in the fractions, but we can work through it. And the next couple of examples, 3 and 4, they work out evenly with no fractions and a little easier to follow. But let's kind of go through the process. So there's my y value. Okay, there's my y value. So now I need to plug it back in. So I'm going to go ahead and plug it into this one because I got to find the x now. So now I go, okay, 43 over negative 9 minus 7. Okay. So when I do this, I'm going to put this over 1, and I'm going to get x equals negative 3. You could cross cancel. I don't recommend it. People tend to make a lot of mistakes with it. 43 times 3 is negative 129 over negative 9 minus 7. And then I can take a 3 out of both of those, sorry, a negative 3, and then x equals positive 43, because a negative and a negative, over 3 plus 7. Then I have to get a common denominator, so I'll multiply this by 3 over 3, because I want to have the same denominator. And I get x equals 43 over 3 plus 21 over 3. Oh, sorry, that was a minus 7. Oops, not a plus. Sorry. So it's 43 over 3 minus 21 over 3. And then x equals 22 over 3. And so my actual answer, just kind of write it right here, is 22 over 3 and negative 43 over 9. Make sure I put the y value second. All right, let's go ahead and take a look at 3 and 4. The same process without the fractions might be a little easier to follow. Okay. So number 3 is 4x equals 3y minus 2, and 18 equals 3x plus y. Okay. So the first thing I want to do is I got to get a variable by itself, and looking at this, the easiest one to get by itself is this y. So I'm going to go ahead and subtract a 3x to both sides. Okay. So I'm going to get negative 3x plus 18 equals y, and once again I'm going to box the two equations that I'm using so don't get confused, and I need to plug that in for the y value right here. So giving myself some room, 4x equals 3 times negative 3x plus 18. Minus 2. Okay. Distributing that in, this 3 right here, I get 4x equals negative 9x plus 54 minus 2. And then 4x equals negative 9x plus 52. Add 9x to both sides. And I get 13x equals 52. Divide by 13, and x equals 4. Okay. So once I find the x value, I go back and plug in for the y value. And so I'm going to go ahead and plug in for, I'll use this equation right here, so I'm going to say negative 3 times 4 plus 18 equals y. And that gives me negative 12 plus 18 equals y. That gives me 6 equals y. And so my final answer is going to be the coordinate point 4, 6.